Hi there, in this video I am going to discuss about C++ Lambda, its syntax to capture list and various usage of it, and this is the GitHub link of the page which contain all the details which I am going to show you in this video. So let's start with the syntax. The details are there, but I'll just show you in the code what is meant by it. So Lambda is written as this, 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 semicolon. This is a valid Lambda, so you have open close square bracket, round bracket and curly braces, and if you compile this particular program, it will compile. By the way, I am using Visual Studio 2015. So that's a perfectly valid Lambda. Just like any other function, you can add functionality inside a Lambda by uh, adding it inside curly braces. Let's say I'm writing test and I'll compile it. I can even run it, but the Lambda function will not run. To run this function, what you need to do is this after the curly braces, just like calling any other function. So after that you do it, you can see it is running successfully. Similarly, you can pass parameters in the Lambda function like this, and you can check the parameter that is being passed, which is uh, by printing, and we can pass the parameter over here just like we are passing parameter in any other function, and you see this is the way it is being done. So that's pretty much it about the syntax of Lambda, and let's see then let's get into giving a name to Lambda in the next section. Now this section is all about giving name to lambdas, and let's see how we'll do that. So the best way to give a name to lambda is to use the C++ auto keyword. So if I just say auto lambda function equal to this, it should be fine. So in this case, what will happen is that I can call this lambda function at any later point of time. Let's say here. So it's giving, sorry, here, and it's giving error because we cannot call it in place. So just to check that it is being called at later point of this, say we'll mark it as T2, and then we'll call lambda function. This is getting compiled, and now I am running. It says test equal to 100. The best thing about giving a name to lambda function is that you can call it any number of time at later point of time, and just like here I am calling it 2 times, one is 100 and another is 200. The auto keyword is a specific to C++, where if you say auto I equal to 100, it will mark I as int. If you say 100.25, it will mark I as float. So auto you can use. The other thing you can use is std for function. It's a template argument. So you will define it like this, and let's give the name LFN only. For function, you need to include a file called functional, yes, and rest everything will be the same. If you compile it and run it, you will see the same output. The third way of doing the same thing is to use plain old C style function pointers. So you can, one thing about it, you have to give return type over here, otherwise the template will not be successful. We'll see later how to use the return type in next section, but you have to give return type. If you want to use C style function pointer, you must have heard about it, like you can do it like same LFN and which takes a parameter int, and pretty much I leave everything as it is, and if you compile this, it gets compiled. So these are the three ways you can give name to a lambda function, but the preferred way will be either use auto or a std function, because std function will be useful in case you need to know the parameter details. So that's pretty much it in giving name to the function. In the next section, we'll see about return types. So now the return types tells you how to return something from the lambda function. So let's say this was the function we were writing earlier. Let's say I want to return something from the, let's mark it first as auto. Let's say I want to return something. Let's say I want to return an integer, let's say integer 100. Let's not pass any parameter for now. So auto rate val. And if we call, remember in place calling, we can call it here like this. And if we just print the ret val, it should print 100. Let's compile it and run it. Yes, it's printing 100. So this is the way you can return from a lambda function. If you want to give a name to lambda function, let's say you are giving a name to lambda function and you are taking a value and your return is actually value plus 1, for example, and it's like this. So you can call this lambda function at any point of time by using LFN. Let's say I want to know auto ret val is equal to LFN 100. I should get 101 over here in the cout. Let's check it. And yes, I'm getting 101. And similarly, you can do again ret val is equal to LFN 200. Just to make sure that it's actually working. It's 201. Instead of auto, you can use int if you know the return type. And let's say 1. So if you do it ret val 1 and compile it and run it, you can see 101, 1201. So this is how we actually return everything from lambda, but surprisingly we haven't specified the return type. Have you seen over here? See, this is one thing which get implicitly written, but if you want to specify a return type, you have to do something like this. This is the actual way of coding lambda which they specify return type. So the return type syntax is this, like this. So for non-trivial type, non-built-in type, you have to specify return type, and it's always good to specify a return type. Sometimes the compiler, I'm not sure, sometimes I found it a bit intelligent, sometimes I didn't found it intelligent. That's why I'm telling it at the end in this video that you have to specify a return type like this. And if you say float over here, you will get a compilation error, at least a warning saying that return type into float. Okay, so this will actually make sure that you get to know the warning or something like that if you're expecting float, especially if you're using it auto. So make it int and a warning will go off. So that's the about return type. The fourth part is extremely important, called capture list. So let's look into the capture list. It's one of the very interesting aspect of lambda. So let's come here. In the last section you might be wondering what this is for. So here comes the capture list. Let's say if you have a local variable called x and y, and let's say you are not passing anything, it's returning n. In the capture list you can pass the local variables as pass by value as well as pass by reference. So let's say I'm just saying x plus y over here. So I'm calling this function. I'll just return it. So I'm calling x plus y over here, so it should give me 30. So it's a call by value. It's compiled and it's giving 30. Similarly, we can specify an ampersand which will indicate pass by reference. So if I pass by reference and do the same thing, it will again return me 30. But what pass by reference means that I can actually increment the x and y, then return x plus y. And so just to check x plus y, I'll say new x equal to x, new y equal to y. Okay, let's see what happens. So x and y is 10 and 20, new x and y is 11 and 21, and it's becoming 32 because it's get incremented before this. So that's the usage of capture list. And the other usage is, suppose you have too many variables. Let me comment it. For example, You have too many variables and you want to pass all the local scope variables in a pi value. You just put a equal sign and that's all. And so equal sign do it pass by value, and if you run it, yes, it's 30, no x is 10, y is 20. Okay. And if you want to pass all the local variables as by reference, use ampersand. Now you can use this also. It's compiled. Now you can see the same behavior. So this is the way capture list is used in lambdas, and it can only be used for local scope. If you are passing by value, you cannot do these two statements, or you can do only after when you are passing by reference. Okay, so that's the way capture list is being used to pass by local scope parameters without passing them explicitly in this. So that's pretty much it about lambdas. I hope you get an understanding on how to use the C++ lambdas. You can anyway go to this GitHub link at any point of time. And thank you very much. Thank you for watching. Don't forget to like it if you really think that you learned something from it. Thanks again for watching. Good day.